Good afternoon. I would like to discuss in today's video session about the thermodynamics equilibrium. Now, a thermodynamics is a device which consists of a substance, and on this device, some energy transfer has been applied, and this energy transfer, the properties of systems are going to change. So, here for any thermodynamics device or a thermodynamic system to be equilibrium, it should satisfy three conditions. One is mechanical equilibrium, and second one is chemical equilibrium, and third one is thermal equilibrium. Now, what is this mechanical equilibrium? Now, consider a product like compressor or any hydraulic pump or something like that. We see that the device must be in a mechanical equilibrium while it is in working condition. So, there should not be any imbalances within the system or between system and surrounding, unbalanced. So, the forces of the thermodynamic device must balance, and then only the device is said to be a mechanical equilibrium. The second one is a chemical equilibrium. As we already seen that a thermodynamic device will consisting of some substance, and when the substance is being subject and the mechanical device is subjected to the energy transfer, the properties of substance will change. Now, if there is no possibility of diffusion or something chemical reaction that has been taken place within the device, then the device is not, or the thermodynamic system is not in chemical equilibrium. So we will ensure that there is no internal chemical reactions that will take place with this thermodynamic device or thermodynamic device. Then it is said to be in chemical equilibrium. So if there is no reaction, no diffusion within the elements, then it is called it is chemical equilibrium. The third one is a thermal equilibrium. Now, in this device, if the temperature the temperature is not uniformly distributed, or there is a possibility of thermal leakage or something. For example, if you take a cylinder and a piston, and we are trying to assume adiabatic expansion. Adiabatic expansion. In the adiabatic expansion, there should not be any heat transfer that will be taking place from system to surroundings. If this cylinder is leaking some amount of heat outside the cylinder, then this system of piston cylinder is not in thermal equilibrium, because we are expected adiabatic expansion. No heat transfer should take place with the system and surroundings. But because of some properties of the cylinder, there is a possibility of heat going outside. Then our graph of PV diagram, which is PV to the power of gamma is equal to constant, will not holds good, and there is this graph is something different with respect to the what need to be expected. So this is what is called thermal equilibrium. So any mechanical device, and for any thermal device or a thermodynamic device, must be in thermodynamic equilibrium. So there should not be no mechanical imbalances between system and surroundings or within the system. And there should not be any chemical reactions that be unstably taken place, because when the device isn't functioning. So no chemical reactions. And finally, there should not be any unnecessary heat transfer that will be taking place with the system and surroundings. Whatever is expected, whatever the heat transfer that is expected, that should be only possible, and no other type of heat transfer is possible in on the thermodynamic. Then only the system, the thermodynamic device is said to be in thermodynamic equilibrium. When the system, then the thermodynamic device will be accepted only if the system is in thermodynamic equilibrium and it is complete functioning. So this is what I would like to discuss about thermodynamic equilibrium. Okay, thermodynamic device. Thank you very much for watching the video.